So hello viewers, as we are discussing the reaction of the carbene, here we are discussing a very important reaction. This reaction is called Reimer-Tiemann reaction. This reaction, when an phenol is treated with 10% aqueous sodium hydroxide and chloroform, it gives 2-hydroxybenzaldehyde as a major product. So Reimer-Tiemann reaction is the reaction or the formulation of the phenols using chloroform in aqueous alkaline medium. So this reaction can be applied to other even heterocycles which are electron rich. They are treated under the similar condition, chloroform and the base in aqueous solution. It gives this substituted it do the formulation, and this sometimes this one is the side product is formed. This is called 3-chloropyridine, and this 3-chloropyridine this product is if this reaction when its formulation is occur, then this is called Reimer-Tiemann reaction of this pyrrole. But when this side product is formed, this is called abnormal Reimer-Tiemann reaction. So this is the substituted phenol. This is at the 4th position, para-substituted position. It has a methyl group. This gives this formylated product as well as this phenol with this abnormal Reimer-Tiemann reaction. They are formed in almost 50-50% or 1:1 ratio of these two products. So this is the general form of the Reimer-Tiemann reaction. The source of the dichlorocarbene or dichlorocarbene precursor. Dichlorocarbene precursor could be chloroform, trichloroacetic acid, even trichloroacetaldehyde. So these are all the source of dichlorocarbene. So this R could be here hydroxyl, could be its H, even alkoxy, even halogens. They can undergo the substituted phenols with these groups, alkoxy groups, halogens. They can form the ortho hydroxy. They can undergo the hydroxy formylation. So the base here used are inorganic strong bases like sodium hydroxide, potassium hydroxide, cesium hydroxides. They are all strong inorganic bases could be used in this reaction. So this is the mechanism of this reaction. As we are starting from the chloroform, when treated with a strong base like sodium hydroxide. Sodium hydroxide takes one proton of this chloroform, and then this 2 electron in this single covalent bond are shifted to this carbon to generate carbanion. From this carbanion, one of this chloro group with these 2 electrons, chloro group chloride ion leaves, and this form are dichlorocarbene. This dichlorocarbene is in singlet form. If this carbon of the dichlorocarbene is sp2 hybridized, then this will make sp2s hybridization with one sigma bond with this chlorine atom, another sigma bond through sp2s hybridization with another chloride, and the 2 electrons, the 2 valence electron of this carbene lies in this sp2 orbital, and this this 2p orbital on the carbon remain empty. So if we calculate the spin multiplicity of this carbene, this carbon is singlet, so these 2 electrons have opposite spin. So one is the formula for spin multiplicity is 2s plus 1. So s is the spin quantum number of the electron. So if we put the value of the spin quantum number of this, these are the 2 electrons, one with clockwise, other with anti-clockwise. So minus half and plus half. So if this 2 into 0, it's come 1. So it means that this carbene which is generated from the chloroform and the sodium hydroxide reaction is singlet. This spin multiplicity is 1. Then this dichlorocarbene reacts with this phenol under the basic condition, because we are using here 10% sodium hydroxide solution. So hydroxide ion takes the proton to generate this phenoxide ion. This phenoxide ion then reacts with this dichlorocarbene. As we discussed earlier, that these dichlorocarbenes are electrophile. So this charge on the phenoxide ion comes here, which makes this double bond between the carbon and the oxygen here, and then this bond makes this carbon, and this carbon makes another single covalent bond here to generate this species. So then this proton shift is occur. These 2 electron of this carbon takes this proton, and this these 2 electrons shifted here, and then this again this phenoxide ion is formed. Then this charge on the phenoxide ion comes back, and then this one of the chlorine atom is removed. So if you see the product here is aldehyde. So there is no chlorine atom. So one chlorine atom is removed here, and then the hydroxide ion then attacks on this carbon, and this charge, this 2 electron is shifted here in the ring to retain this, and then this 2 electron is shifted on the oxygen to generate again this phenoxide ion. And then later on this again the phenoxide ion charge comes back, and the second chlorine atom is in the form of the chloride ion is removed to generate this intermediate. This species is then undergo the tautomerism. This because in the tautomerism the position of the atoms, likely the hydrogen atom is changed. So this hydrogen atom is shifted to this here. So after the tautomerization we get this 2-hydroxybenzaldehyde as the product. So this is a very important reaction, Reimer-Tiemann reaction, and this is the detailed mechanism of this Reimer-Tiemann reaction. So this reaction has very good applications. If this phenol is substituted at this para position, if this alpha position is substituted, then this formylation occur at the para position. So thank you very much students for paying attention. Thanks for watching this video.